All right, so for number 50, we have an untreated sugar cube, and it does not burn when held over a lighted match. But if we take a sugar cube and we coat it with some cigarette ash, it readily ignites and burns. First of all, I'd like to define the word readily, because sometimes people read that and they're like, I don't know what that means. Okay, so the word readily means easily. All right, and if you forget that and you come across it on a test, what should you do? Ask me, okay? Because that's the kind of question I can answer on a test. I'm not going to be able to answer questions that, give you the answer, but a vocabulary question like, it's not a chemistry word. It's not like you're saying, oh, what's the definition for an activated complex? You're saying, what's the definition of readily? I can readily tell you that. I can easily tell you that, okay? So this cigarette ash, once we got the cigarette ash on the cube, it burns. All of the cigarette ash remains. So none of the cigarette ash goes away after the reaction. So do we know of something that does not get used up in a reaction? A catalyst. And it sped it up. So it did not happen without the catalyst. It would happen with the catalyst. So obviously the flame wasn't enough to burn the sugar without a catalyst, but the catalyst lowers the activation energy, so we can then. Okay? Can it be a no? Because the reactant is still the sugar cube. Does that make sense? Yeah, cool. Hi. Yeah. Oh, I'm going to have to print another one for you. Okay. Yeah. Sorry. People kept saying, oh, I don't have one. Oh, I don't have one. So all my extras have been used up. But yeah, I'll grab you one. All right. Next question. Did you have one? 84. Didn't we do 84? Oh, we should be connected. So. 84. Oh, I should make this smaller, then it'll go faster. Okay. 84, we did 84. Oh, you weren't here yesterday. Okay. It's on the video from yesterday. Okay, so check that out. It basically has to do with it has to do with the stoichiometry. So the coefficients. So you have to make sure that, like, if it's 1 to 1, they should change at the same rate. If it's a 1 to 2, one should be changing twice as fast. One should be changing half as fast. Okay. Other questions? Yes. 78. Which of the methods above would be the most suitable to investigate the rate? So we want a method of measuring the rate of this reaction here. So I want you to take a look at that reaction, and even without the choices, can anyone think of something that you could use to measure the reaction? Concentration of what? What would be an easy thing to measure the concentration of? The hydrogen ion. So let's go and take a look. Is that any of them? No, it is not. Okay, so we have to go back and say, well, darn it. Quenching the reaction followed by titrating with an acid. That means reacting with an acid. That would be testing for a base. And do we have a base here? No. So that's not going to be helpful. Measurement of the change of mass of the system. Will this system change in mass? Under what conditions do we have the whole system changing in mass? When we have a gas, because the gas can go away, right? Otherwise, if it's aqueous or solid or everything, it just stays, right? It doesn't go anywhere. All right, so it's definitely not this one. It's not this one. A change in volume. Do we like a change in volume? What do you need to have a change in volume? You need to have a gas, a change in the number of gas molecules. No gas, that one doesn't work. So it's got to be a change in conductivity. Now, you can do it by process of elimination. You can also look and say, over in the reactants, I have an ion, I have 5 ions, and I have an ion. Ions conduct electricity in solution. So over here we have 11 plus 1 is 12 ions. And over on the right-hand side, how many ions do we have? What makes something an ion? A charge. None. So over here we have 0 ions. Yes? Because Br2 is not an ionic compound. It will not dissociate. Water is a covalent compound. It will not dissociate. So on the left, there's 12 ions. On the right, there's 0 ions. What will happen to the conductivity as this reaction proceeds? Will it increase or will it decrease? Conductivity will decrease because the number of ions decreases. Okay? Alrighty. Sorry? D? Oh, quenching, stopping the reaction. Okay, so stopping the reaction just means you add a chemical to stop it. Okay. And then titrating with an acid. We did a titration last year. Do you remember? Drippy, drippy, swirly, swirly. Yes? Okay. And the premise of a titration, we will do some other titrations, but very often it's going to be a base plus an acid gives a salt plus water. Yes? So if we are titrating with an acid, that means we need a base for it to react with. And so we look at our reaction and we say, do I have a base over here? No, I have an acid. Yeah, because I've got H plus, and the H plus ion is the key part of the acid that makes it an acid. Okay? Yeah. Quite frankly, I wouldn't expect you to be able to explain that on a test. And I probably wouldn't even give you a question like this with an option like that on our test until after we have done the acid-base unit. But because this is a review, I can throw anything at you almost, right? Yeah. So don't worry, you won't get that one on your test on Friday. All right. Other questions? I want to get an idea of how much of this you guys have done. So what you're going to do is if you think you've done more than half, you're going to put your thumb up. If you think you've done less than half, you're going to put your thumb down. If you think you've done in the middle, you're not really sure, you're going to put your thumb to the side. Okay, so I've got some, okay. So all of you who have your thumbs down, you have had this since last week, yes? And how many days were on your weekend? 4. It was a 4-day weekend, yes? So, and many of you, I'm assuming, would be like, what are your goals in this course? I don't know, maybe getting a good grade, yes, right? And if you have a 4-day weekend, now I know there's some people who have things, I've had people who have had a scout camp and it's taken the whole weekend. And if that was the case for you, I am not talking to you. But if you had the weekend and you have a calculus test and a chemistry test this week, and you're like, oh, but I really would like to play this video game, and I stay up late and I do that, that's not going to be a successful technique for success in grade 12, and it certainly won't be a successful technique in university. And I will say that many students get to university or college or whatever, and they flunk out because they just don't have the work habits yet. Okay, so this is a proving ground for you. This is a chance to practice those work habits. Does anyone have any other questions from here that they'd like to go over? Yes. 48, absolutely. Let's do that. There we go. Okay. We have solid zinc, and we have added some 1 molar HCl. 1 molar HCl. And in 20 seconds, so the time is equal to 20 seconds, the temperature of the container increased by 0.5 degrees. So the change in temperature was 0.5 degrees Celsius, and 25 milliliters of H2 was produced. So the change in volume of H2 was 25.00 milliliters. And we would like to know the rate of this reaction. What is the generic formula for the rate of a reaction? Tell your partner. Change in amount over change in time. Okay? Key thing here is that it's got to be time on the bottom. That is the constant. You can change what the amount is. It could be a volume, it could be moles, it could be molarity, it could be mass. Okay, that amount could be many different things, but the time is always going to be on the bottom because that's what a rate is. Okay, so we have 2 options here. We either have a change in temperature over a change in time, or a change in volume over a change in time. Why am I not tempted by this 1 molar HCl? Do I know that I'm using up all of the 1 molar HCl in that 20 seconds? Does it say that anywhere? No. So I might still have some left over. Yes? But what I do know is that my temperature increased by 0.5 degrees, so that's a change in temperature. And I know that I started with no product, so I didn't have any H2, and it increased to 25 milliliters. So I know that the change in volume, okay? I don't know the change in molarity because I know I started with 1 molar, but it does not tell me how much I finished with. It doesn't say it got all used up. So I need to then take 0.5 degrees Celsius is how much it changed in 20 seconds, and 25 milliliters is how much it changed in 20 seconds. I can immediately eliminate B because it's molarity and we don't know the change in molarity. I can eliminate moles probably because it's a multiple choice question. And in order to calculate moles of HCl, I would have to take my volume of H2. I would have to know the temperature in order to calculate the moles, because if I have a gas, the moles depends upon the temperature. And this is starting to sound like an awful lot of work for a 1-mark multiple choice question. So I'm going to look at that and say, I don't have an obvious moles of HCl, so I'm just going to leave that alone. You actually don't have enough information to solve that because you do need to know temperature. It does not say that it is at STP, and besides which the temperature is changing over time. So we cannot figure out the moles of HCl because we would need to calculate it from the H2, which is a gas. So, which of these two numbers matches up with its respective answer down here? A? C. Because it's over 20 seconds, you have to do the division, yes? All right, so this would work out to be, I don't even know what that number is going to be. 5 divided by 20 is, blah, 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 blah. That's like what? A quarter? 0.25? Okay, so if it said 0.025, yeah, 0.25 degrees Celsius per second, that would be an okay answer, but it doesn't. So this one would be 1.25. So this is our correct answer. Any other questions? 87. Okay, this is another stoichiometry problem. Okay, so we have here, when we're talking about relative rates, we're always going to be looking at stoichiometry. So we're going to be looking at the ratio of coefficients. So the ratio, there's a 1 and a 1 and a 2. So it is a 1 to 1 to 2 ratio. So whatever HBr should be twice as fast as H and Br. Yes? Okay. So HBr will be produced at half the rate. No, it will be produced at twice the rate. Yes, because there's 2 HBr for every 1 bromine, not a half of an HBr for every 1 bromine. Okay? HBr will be produced at the same rate. No, because they have different coefficients. Different coefficients. Different. So they cannot be at the same rate. It should be 2 times the rate. Okay, Br2 and H2 will be consumed at different rates. No, why not? Same coefficients. HBr will be produced at twice the rate that bromine is consumed. Yes. And it is not possible to tell anything about the relative rates of consumption and formation. That is not true, because if you know the coefficients, you can tell the relative rates. Now, if I had to do this question and I didn't know anything about it, if I had to guess, I would look and I would say, A and D are exactly the same, except for one is half and one is twice. So I would be like, okay, it's probably one of those two. And now I've got it down to a 50-50 choice and I can make a guess. okay? So there is a little bit of multiple choice gaming that you can do if you really don't know, right? You can eliminate choices you know are wrong. That gets your odds to be a bit better because you always, if it's a 4-answer question, you have a 1 in 4 chance. Never leave a multiple choice question blank, okay? Fill in something. My favorites are B and C because those are usually like, they want to hide the answer in the middle. You know what I mean? Right? But it doesn't matter. I do have a version of a test. I don't know if it's reaction rates or some later test where there's a lot of B's in a row or a lot of D's in a row or a lot of C's in a row or A's in a row. It's okay. It's random distribution. So if it goes A, and you're like, oh my God, that's 5 A's in a row. That must be wrong. No, don't do that. That's not how probability works. Okay, probability works. You roll the die, 4-sided die, and you just get 1 through 4 every time, and it could be all ones in a row. Okay, so don't worry about that nonsense. All right. The other thing is too, if you are writing a test and you get stuck on a multiple choice question, what should you do? Tell your partner. You're stuck on a multiple choice question. It's question 10. What should you do? Skip it. Do you get stuck and like ponder over it for 10 minutes? No, because the next, there's going to be 21 multiple choice questions on your test. If you get stuck on number 10, then you don't have as much time for 11 through 21, and those might be way easier, and you could get all those marks, right? Not rush through them, like if you got stuck on number 10. Plus, if you get stuck on one question, you might be going through the written response, and you might be like, oh, this question is like, it's like that one, right? And you'll be like, oh, you know what? The answer to this question is actually in this one. Oh, right? That happens sometimes. So look out for things like that. Play your exam smart, okay? All right. Does anyone else have any test strategies that they like to use? Those are my big ones. Okay, good stuff. Other questions? Any other questions? All right, I'll tell you what I'm going to do. Yes, sorry. 5. Which one of the following is true about the activated complex in a reaction? Is an activated complex a catalyst? No. Okay. So look, we've eliminated one answer. Okay, that's good. Is an activated complex stable? No, it is unstable. Does it always form products? It doesn't have to, because if you've got an unstable substance, and I don't know if I really stressed this, so thank you for asking this one. If you got something unstable here, it could fall this way, or it could fall that way back to reactants again, okay? But I don't believe I stressed that, so that is a very good question to have asked. So it is false. And then finally, it possesses more energy than the reactants or products. That's true. So you probably could have gotten that without knowing that C was wrong. However, there might be a different question that asks that in a different way, and it's good to know. Okay? Yeah. Yeah? 16. Which of the following is most likely to have the highest rate at room temperature? Everybody, do this question now if you have not already done it. Highest rate. So our fastest reactions are those that involve what? Aqueous ions. And in fact, you could just say ions because you're not going to have any ions that aren't aqueous. Yes. But double replacement, the double replacement are aqueous ions. Yeah? Especially double replacement. Because any double replacement reaction, let's just take a look at a really simple one. We have silver nitrate, AgNO3, aqueous plus NaCl. Aqueous goes to AgCl solid plus NaNO3 aqueous. If we were to then write the net ionic equation for that, we would have Ag plus NO3 minus plus Na plus Cl minus goes to AgCl solid plus Na plus NO3 minus. And we could cancel out the NO3s and the NAs. Yeah? So what you see is that you have, so is there a double replacement reaction in the answers to question 16? Yes, this is a double replacement reaction. Because where did the magnesium come from? It had to have been partnered up with some ion, probably nitrate. So what we probably had was magnesium nitrate. Yes? Yeah. And where did that hydroxide come from? It had to be, that hydroxide had to be partnered up with some sort of cation, probably something like sodium. Okay? So, because neutral is stable, and having a bunch of positive charges around each other without a balancing negative charge is unstable. Because positive does what to positive? It repels. So if you were to get, like, let's say you were to walk into the back room and try and get a jar of Mg2+, you could not find it because if such a thing existed, it would explode. Yeah? But they just don't exist that way, because how did Mg2+ become Mg2+? It had to have given away 2 of its electrons. Who did it give them away to? It would have given them away to some sort of anion, because that's how the anion got its negative charge. Yeah? Yeah. Excellent question, though. Okay? So, back to this, our fastest reactions are aqueous ions, especially double replacements. And so we could say aqueous ions are faster than gases. They are faster. Oh, and I shouldn't even be pointing at this gas. Why should I not be pointing at this gas? Because it's a product, and the products do not matter in terms of rate. Okay, so I can ignore that, but I do have gas here and here, so that's going to be slower than aqueous ions. Here I've got a liquid and a gas, that's going to be slower than aqueous ions. Here, I do have aqueous ions. I got a whole schwack of them. Yes? But it's very complicated. I've got, how many particles do I have there? 5, 21, 23 particles, 23 reactant particles. That's going to involve a lot of, this is going to be a multi-step mechanism, yes? Yeah, so yeah, that'll be slower. Okay, so D is slower than B. Huh? You know what? Honestly, this question I would not ask you, which is the slowest. Because you don't really have enough information to judge which is the slowest from this. You do have enough information to judge which is the fastest. Okay? A slowest reaction would be solids. What is wrong with it? Yeah, solids. Other questions? Yes? 112? Perfect. Which of the following statements is true in relation to thermodynamic changes? Now, you might look at this and you might say, what on earth is a thermodynamic change? Yes? You could, if you needed to on a test, ask me, but first you're going to say, do I actually need to know what that is, or can I just go with the rest of the information? Let's try just going with the rest of the information. So which of the following is true? Is it true that a system undergoing an exothermic change releases energy? Is that true? Yes. Is it true that if the surroundings are absorbing energy, the system must be undergoing an exothermic reaction? Somebody asked me this morning, and I think I didn't read it properly. Because if the surroundings are absorbing energy, right, we've got our system, and we've got the surroundings. If the surroundings are absorbing energy, there must be an energy transfer from the system to the surroundings, so that would be an exothermic reaction. So if you were the person asking me this morning, I am sorry, I think I said it wrong. So this would be correct. And then a system undergoing an endothermic change. So here's our system, and here's our surroundings, will absorb more energy than the surroundings releases. Does that make sense? That I get a different amount of energy, like energy just moves, right? You can't have one thing making energy and the other thing taking up it. Like the energy is moving. If you're moving 10 kilojoules, you're moving 10 kilojoules. You can't have a different amount. So it would be, I believe it should be 1 and 2 only. Okay. Yes. Why is it not 3? If my system absorbs 10 kilojoules of energy, how much energy must be transferred from the surroundings? 10 kilojoules of energy. So is it possible for the system to absorb more energy than the surroundings release? So if it absorbs 10 kilojoules, could the surroundings be giving 5 kilojoules? It just doesn't work. Yeah? Yeah. Yeah. Hold on to it in what sense? That's called potential energy. So that would be what it does. So you would take, there would be 20 kilojoules of, or say 10 kilojoules of kinetic energy in the surroundings, which then transfers into the system and gets transformed into 10 kilojoules of potential energy. Yeah. And if you're wondering about thermodynamic changes, thermo has to do with heat. Dynamic, changing. So the changes in heat has to do with changes in heat. But you don't need to know the word thermodynamic. But that's another test trick. If you don't know a word and you don't want to bother asking about it, you can just kind of see if ignoring it works for you, because it's not actually, you can just be like, can I tell if they're true, or do I actually need the word thermodynamic, which it turns out you don't. I wouldn't give you one like that on a test, because I try not to throw random words at you in a test that I don't think you'll know what they mean. Other questions? Alrighty, if I were to give you the rest of the block to work on this, would that be a popular thing, the review? If you're already done and you would like to start taking a look at the new unit, I have the new unit available. Okay, so let me know. So if you work through everything, yes? Tomorrow we're going to start our new unit. Okay, I will also answer questions if there are more, but we're definitely starting the new unit tomorrow. Okay? Is there anyone who would like the new unit today? Yeah? Probably. Yeah, no, I think it is. I don't know that it's. Turns out we did. Okay, yeah. I don't know. No. Well, plus we want to make it in their house. No. Hi. Side before spring break. Okay? I'll let you know by spring break. Yeah. Good that one. No. No, but here's the thing. In unit two, we look at rates in terms of back and forth. And then in unit three, we look at back and forth in terms of solutions. And then in unit four, we look at back and forth in terms of acids and bases. And then in unit five, we look at back and forth in terms of more acids and bases. Right. And then unit six is completely different, except that it sort of works a little bit like acids and bases. Oh gosh. In that you've got reducing agents and oxidizing agents, which sort of have a little functions like acids and bases. So, just like honestly, Kitchen Street 12 is a beautiful, gorgeous course in the fact that it all ties together. Yeah. Yeah, I'm just a little bit chill about it. That's how much of a chemistry you're level up. Yeah, beautiful course. You guys call me over if you have questions. I'm going to be marking your quizzes in the meantime because I have not finished them yet because I have 2 blocks and that's like 60 quizzes. So yeah. Yeah. Okay. So we have no gases, so we don't want anything to do with gas. Finding the mass of one of the reactants, everything's aqueous, so how we want to separate them, that's not important. I'm using spectrophotometer to determine the change in H plus concentration. H plus doesn't have a color, it has a color with this one. A spectrophotometry is measuring the color. Okay, on your test, I will not expect you to know that. Okay, I'd be like measuring the color of the H plus. Okay, yeah. In fact, it's Well, well, this one is all the, so there's blanks. Class, you don't want to video. You can go over right? Yeah, so, that's my. Anyone questions? Okay, I'm just gonna be marking your quizzes, just come on up and see me, okay? Don't be shy. Do you have a question? It's not, that's okay. Doesn't need to be. It will be of similar difficulty for the quizzes. Okay? Yeah. There's easy questions, and then there's challenging questions. Yes? So especially like if in the written response, I've actually put them in order from easiest to hardest, so that you can get your cheat marks first. And then you're like, okay. You just feel good at the beginning. You can feel, well, A, you feel good at the beginning, but B, you don't waste a lot of time trying to like work through this more difficult question, right? So yeah, I try to do that. I don't always manage because sometimes the pages, like it won't fit properly, but I try to. This time it's oh, Spark. Here. Spark. That's it? Yeah, that's what a Spark is. Yep. Yeah. No. That's why it's sometimes easier to have like an actual physical thing, but it works. Yeah. Do not neglect your written response questions. I know that multiple choice are easy, nice, juicy, but do not neglect your written response copy. Yeah. That one is A because you see how these are ions, so you have a ion. See how these are not ions? So ions conduct electricity in the solution. So here you'll have lots of conduction, so you'll have no conduction, so the conductivity will go. Yeah. 21 multiple choice, and then 13 written response marks. 5 questions, 32 marks. 21. Yes, I did 21 and 13 because it just worked out that way. Like I had a couple of questions that I really wanted to know. To get rid of them, and like I was like, okay, I'll just give a couple marks off of the written, and you guys will probably be happier anyway. Thank you. Yeah. Okay. Yeah, thank you. What? Oh, landscape. 2 by 1. What the actual frick? There we go. Okay. Print on both sides of paper. Okay. 1 copy. Print. Let's see if there's anything else. This is for the test. Oh, I mean, there will be stuff that we put on there, but it's listed in everything, right? So it's, yeah. Oh, okay. So what happens to rate? No. Yeah, because why? Articles. Higher temperature particles bounce or slow bounce. The lower temperature particles slow. So what can happen in a number? What's going to happen is energy is split. Particles are moving slower. No, okay. Yeah. Yeah. We can't assume that. And then the problem with this one, this problem with this one. Yeah, because you can't change. Since we're students, yeah. Are they newish? Like since last year. Yeah, since last year. I mean, I've noticed them before now, so yeah. Thank you. obviously math and chemistry too, and physics. Teach yourself math and chemistry. Of course, it's physics. Oh, yeah, and we don't have any help. Yeah. I wouldn't even know about that. Uh-huh. No, that's okay. How did you get that? Oh, still about. They stabbed in the theater. So how is it been for? You're just writing on here. Oh, so forward means going from reactants to products, reverse means going from products to reactants. Okay, and I'm not going to do the test because. Yeah, yeah, we'll do that for next year. I said I was just looking at my answer and I was like, taller. Yeah. Would either say I say I would decrease the by. Yeah. Is that? Yeah. So if you just said you can volume, that would be. Yeah. 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 True. So it has to be a, yes, but not right. Okay, so Fe2 plus is a reactant, so it's decreased. Oh, that's the simple fact. Yeah, so this one, because you don't know Q, you get the body processing function, but later on, you will learn that as hydrogen ion decreases. For now, but.
Are you gonna get a better calculator?
That's the best calculator, I'm my favorite calculator. I have that calculator, it's my favorite
Can't do
calculator.
it twice. Isn't it easy? It's so fun, like, going to the trash can and.
See, I'm a scientist, so fractions are like, that was too useless, right? Because we never do anything with fractions, and it's always irritating to have them there, and the person has to do the multiplication of the fraction.
Oh, yeah.
I'm like, oh, why do I have to push a button for that? Ugh. Everybody has an outline for the test, yes? Oh, yours would be salmon colors. Yes, okay, good.
Where's that? It's this one, right?
Yeah, that's the one.
It's a salmon color, but.
Yeah, that's salmon colored,
Different color.
kind of, yeah. Those are like from a previous year when I didn't have that color.
I thought it was another one.
Yeah, no, it's the same thing, yeah. But I just don't have that color paper anymore. So I was like, okay, it's kind of in the same color family. It's like, yeah.
Oh, 31. I think it was Stephen on the test,
What? What? Anyone have any questions? No? Okay. I'm trusting you to come up here and ask if you have any, okay? Hi. Okay, it has found the addition of manganese causes an increase in reaction rate. What conclusion can be drawn from this? Okay, so we have manganese as a product. Yes. So if increasing manganese speeds it up and it's not a reactant, then it has to be a catalyst. Yeah? Because there's no other reason. Like if you're increasing concentration of any of these, that would speed the reaction up. But that shouldn't do anything unless it's a catalyst. Yeah? No. Hi. No. So when you have an exothermic reactant, the products are lower potential energy, so they're more stable. Which is one of the reasons why exothermic reactions are much more common than endothermic reactions. But if it could, but sometimes it won't. Other factors play that we learn about this too. Yeah. So things like to be more stable. So this is actually one of the driving factors for reactants. Is if you get more stable, yay. Yes. Which is exothermic. So exothermic is favored by nature. Okay, but we can have this happen because there's another factor that comes into play called entropy, which is like in the philosophy system. It's not a really great definition, but it's a really skim over it. So basically, nature wants everything as random as possible. So if things are becoming more random, then you can make this can option. Don't worry, we'll talk about that in unit 2. You don't need to know any of that for unit 1.
I see, yeah. Why would you do that?
Another one bites the dust. Another one bites the dust. Another one down. Another one bites the dust. One student dropped out so far. Another one bites the dust. Look it up. Another one bites the dust. Another one bites the dust.
Just let him do it. It's crazy.
My problem is I don't know. Well, Frank Mercury doesn't evaluate stuff.
The man who was on fire, why just-
Yes.
Yeah, the one that says. I only know that.
Yeah.
Because the song is there.
Yeah.
That's it. Well, I don't know if they're sort of like, exactly.
They may have, one, people say, oh, these ones are wonders, they don't have it like that. And I'm like, yeah.
The university.
Yeah.
Based You only do one.
We sometimes have like.
You don't have to, it's like, only writing. Like, only writing and like, you can study from, you really have to like know.
It's called.
Yeah.
It's she's like. Everyone's.
Well, I would, because I usually have too much work. Like,
I understand.
right, so.
Maybe other teachers.
Right? Because I understand. What happened to me? Don't know. Obviously, me. Then you don't make, then you don't have to back before the test, you don't get feedback, right, before the test. You don't know, there's no, don't know,
Yeah.
before the test.
Yeah. Like you,
Done.
they just feel me. From being past previous. You remind me of that.
Right, so would it be nice to talk about, like, what they look for?
My problem is my child is very.
I would think it would be just. That's it.
What embarrassing.
Then that would be the big. I'm not sure I can do it all. I love it. I love God. Yeah, like I love.
It's easier. like we alternate. Fine. You absolutely can now. Yeah, the pool is good. I don't want to watch it. Yeah. Just to see if you know about
Yeah, help yourself. It's just the blue book and then the answer key's right in front of it. Okay, where did it go? Back here, green, green. Green reaction mechanisms. There we go. All right.
Thank you. Spence,
Yes,
by any chance, do you have the tests on 1.6 and 7?
the quizzes. What? 1.6 and 7? There's no 1.6 and 7. What?
There was 1.6 and 7.
Oh, what? Oh, for the AP. Oh, there's no
printed
test.
out.
There's no test for that. They don't